Good day, my name is Alicia Tijani and this is my submission for the bonus project for ECS 1021. We were For this project we were tasked with using Java as the main interface for with our hardware of Arduino in order to create something that uses sensors, that uses the APIs in Java, and that also solves a problem. So my submission for this for my submission for the bonus project is a sound operated oscillating fan using a servo motor. So here's my setup. This is my console for the Arduino. This is my servo motor, and here's my growth board and the LED light, which will turn on as the light as I clap, and here's my sound sensor. So now I'm going to run the code. I'm running the code, and now I'm going to make a noise. As you can see, it signaled, senses the noise, and it moves. And now I'll make another noise. As you see, it keeps rotating. It rotates as soon as the noise is heard. And also the LED light starts turning on as you can hear my voice and the loud sounds, which enables it to work. Thank you very much. And here I created a class called Sound Listener that listens to the chain that has the sound sensor code, which the sound sensor then changes to the servo motor, which enables the servo motor to work. And so how my project relates to the following CLOs is, for the first CLO I used a testing program to test my code, which will be included in my source code for the bonus project. For this, and I also checked to see whether the rotations are accurate using a protractor. And for the second CLO, I used different libraries like the Fermata 4J library. And originally, I was going to add a temperature sensor, but it had to be cut out the com- due to the complexity. But with that, I was going to use the Fermata 239, which I downloaded into Java. So it is what I used for this project. For the fourth course learning objective, the events that I used to decide what I was going to do with the code was whether there was a threshold for sound that the sensor would acquire, which will lead to the fan turning on. So there's a state of when there is too little noise, so it would assume no one is there, and then there's a state of a lot of noise when it would assume someone is there and the fan will start to work. And with the DHT sensor, it was going to register temperature, which would then lead it to turn on if it's too hot, or cold if it's too cold. Turn off when it's too low. Under CLO 5, I was able to use encapsulation to make sure all my servo logic was contained within the servo listener class, which I adapted from the button listener class that we used in one of our labs, which helped neaten up my code. And I also used event driven programming using the IO device listener, which helps to take info from the board, then do a physical activity because of it. And I believe my project will help for those who may not be able to physically use their hands to turn on a fan, and it can also help clear the air when there are multiple people around, as a sort of, in terms of air circulation control, which would help when there are a lot of people around and it will not be as convenient to be turning on and turning off the fan, especially when in those situations it will be more stuffy, which makes my project holistic. Thank you.